Welcome back. Today I'd like to talk about the distance formula. After I ask you this question, go ahead and pause your video and think about it for a second. How might we find the distance between points A and B? Point A, in case you can't see it, is 2, 1, and point B is 7, 3. How might you find the distance between those 2 points? Here's your clue. How about you use the Pythagorean theorem? Still perplexed? What if we put a point right here on our graph? And by doing that, you can probably all see there are 3 points form a triangle. Let's call that last point, we'll call it C, and it's obviously at 7, 1. Now we have a triangle which might make a little more sense when I say use the Pythagorean theorem. Okay, we know that this is a right triangle, don't we? Because our lines on our coordinate grid are perpendicular to each other, so we know that this is going to be a right angle right here, which means that AB is our hypotenuse. So let's write down our equation. We know A squared plus B squared equals C squared. So in this case, let's substitute AB, and that just means the length of side AB, that's what that AB means, squared, plus, oh, I'm sorry, I messed that up. That should be AC, because we're going to talk about this guy down here, plus BC. That means the length of BC squared is equal to, and now this time you should use the hypotenuse, and that is AB. So now we've got AC squared plus BC squared equals AB squared. Let's plug our numbers in. Obviously, you're going to tell me that I can just count to figure out this distance. And it is 5, but I'm going to write it in a special way. The way we get 5 is we say, let me take my x values from point C and point A, and let me subtract them. So 7 minus 2 is going to give me 5. But I'm going to write it as 7 minus 2 for a second. Then, to find the length of BC, you would probably just say, Mr. Dudek, please just count up. It's 2. It's obviously 2. Okay, but my question is, how did you figure out that that was just 2? Okay, you counted. But I might say, well, since I have my y values here of 3 and 1, why not subtract those? 3 minus 1. Obviously, it's going to equal 2, but please humor me for a second. And AB, the length of side AB, we still don't know. So here we have our equation, and all we have to do is solve. So 5 squared plus 2 squared equals the length of AB squared. So 25 plus 4 equals AB squared. So 29 equals AB squared. And hopefully you remember how to solve for the side length AB. You've got to take the square root of both sides, because when you do that, our square and our square root symbol cancel each other out, and you're just left with the side length AB is equal to the square root of 29. Or if you'd rather, it's approximately 5.4. Either one of those answers would be perfectly acceptable. Now, if you're confused as to what I just did there, take a minute to consider this. So I said 7 minus 2. I took my x value from point C, and I subtracted my x value from point A. that found the distance of AC. So this is the difference in my x values. You don't have to write that, but just note it. Same with this next part. What does that make this part right here? 3 minus 1. It's the difference in my y values. That kind of catapults us into the next part of the lesson. Okay, the distance formula is right here. It's going to tell us how to find the distance between 2 points on the coordinate plane. We say d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Remember, guys, you can always pause just to write things down and then turn me back on. Okay, this might look confusing as well, but please remember that this 2 and this 1 and this 2 and this 1 have nothing to do. They are not exponents. These are just markers, okay? So x2 is a point, or x2, y2 is a point. Just like 3, 4 is a point, and 5, 7 is a point. If we wanted to find the distance between those 2 points, we would say that this point is x1, y1, and this point is x2, y2. Okay? The 1 just means this is the first point, and the 2's mean that this is the second point. So, the distance formula, it looks confusing, but really, since we know how to work with equations, we can manipulate this a little bit, make it look like what we already know. Since it's an equation, we can square both sides, can't we? Okay, so what are you left over with is d squared equals the squared symbol and the square roots better cancel out, and you have x2 minus x1 squared plus y2 minus y1 squared. Guys, all of a sudden, this means the distance of one side is equal to the distance of one side squared plus the distance of another side squared, which really should remind you of the Pythagorean theorem. So basically this means hypotenuse squared, or d squared, equals one of our side lengths squared plus our other side length squared. Now let's try and apply it. Just have one example today. I want you to find the perimeter of triangle DEF, where D is 0.12, E is 50, and F is -3, -1. Now, you all could, if you'd like to, although this is the long route, just watch me, do not write. You could draw your coordinate plane, and you could graph your points. You could go 1, 2, and 50, and -3, -1. Okay, you could draw your triangle. Nice triangle, Mr. Dudek, as usual. There's your triangle. And if you wanted, you could use the Pythagorean theorem to find the length of all of these legs. So for instance, to find DF, you might draw a point up here. Now that this is a right triangle, you could do what we just did, and you could find the length of this side, the length of this side, and use the Pythagorean theorem to find this. However, this is the long route. The great thing is we can use our trusty distance formula. So let's try and recall that. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we decided we wanted to use the distance formula to find the length of side DE, it might look something like this. Since point D is 1, 2, and since point E is 5, 0, you can choose whichever one you want and make it your first point. I'm going to choose D. So I'll call that x1, y1. I'll call E x2, y2. And now it's very simple. I can just plug in my values directly into my formula. So x2 happens to be 5 minus your x1. Make sure you don't forget your squared. y2 is 0 minus y1, which is 2. Also, don't forget to square it. Now we just have to evaluate. Okay, 5 minus 1 is 4 squared. Negative 2 squared. And let's just continue. So you've got the square root of 16 plus 4. And finally, you should have the square root of 20. Or you would say approximately 4.4. Okay, that does not finish our problem. That only gives us the side length, DE. Still have to find the other two side lengths. And of course, since we're looking for the perimeter, we'll then add them all together. So I'm going to move a little quicker now. If you need to, you can pause. To find side length DF, I'm going to do the exact same thing. I'm going to make D my first point, and I'm going to make F my second point. So I'm going to name that x2, y2. Okay, so you can think of this as a completely different problem almost than the first part. I'm still using x2 and y2. Okay, so here we go. x2 is negative 3 minus x1 is just 1. Square it. y2 is negative 1 minus y1, which is 2 squared. Now as we continue forward, pay close attention to your negatives. Negative 1, negative 3 minus 1 is negative 4, and it's still squared. Negative 1 minus 2 is negative 3, and it's still squared. What you should notice is that you're never going to have a negative number inside of your square root. Okay? Negative 3 squared is positive 9. So side DF is the square root of 25, which you all should know is 5. So DF, the side length, is 5. And we have one more to go here. You guys are doing great. Side EF. Same exact process. If I were you, I would try this on your own. Pause the video. But here we go. I'm going to make E my first point. I'm going to make F my second point. So here we go. Y2 is negative 1. I'm sorry, X2 is negative 3 minus x1, which is 5, squared plus y2 is negative 1 minus 0, and it's squared. You have negative 8 squared. You have negative 1 squared. And so you have 64 plus 1, which equals the square root of 65, which is approximately 8.1. Therefore, your perimeter is going to be all three of these added together. 4.4 plus 5 plus 8.1 is approximately 17.5 units. So folks, there you go. Hopefully tomorrow when you come in, we'll be able to work a little bit more on this. Just to sum up, you should walk away. You should be able to say this to yourself. I can find the distance between any 2 points on the coordinate plane using the distance formula.